Okay, so options are a type of financial derivative that gives the owner the right but not the obligation to purchase or sell a specific asset at a predetermined price on or before a certain date. One of the main determinants of the price of options is the volatility of the underlying asset, and multiple studies have shown that implied volatility is a better tool than historical volatility to estimate future volatility on the underlying. In this paper, we will investigate the use of a Bayesian method in order to yield a better estimate of future volatility than historical volatility of stocks without the use of implied volatility. This method can be useful for stocks that have no existing options traded and where therefore is no implied volatility data to refer to. This paper is an extension of the work done by Ho et al. The underlying asset we picked is the SPY, which is an ETF that is designed to track the S&P 500 index. We will be focusing on the 30-day historical volatility. The implied volatility data comes from the VIX, the CBOE Volatility Index, which is a measure of anticipated movements in the S&P 500, derived from the current traded prices of S&P 500 options. The time frame for the data is from November 1st, 2017 to April 10th, 2019.
We assume that the daily returns are log normally redistributed with a mean of 0, and from there we can produce our likelihood function for the volatility. And then we use three different prior distributions, including the inverse gamma prior, the gamma prior, and the truncated normal prior, to see which distribution performs the best in comparison to an existing measure of volatility.